Sat Shri Akal students, today we are here to learn about buoyancy. Students, you must have observed so many times that if you see a cork in a water tub, the cork or the foam or some plastics, they always are on the top of that tank having water or any other liquid. If you observe that iron, you never observe iron is floating on the top of a tub containing water. Iron always sinks down. So this is the case of sinking. This is the case of floating. We call it floating. And you must have seen sometimes you have some materials. I don't remember some materials, but some materials, uh, they will neither float, they won't be here, they will neither sink, they'll be in the middle of, you know, the tank containing water, maybe here, somewhere, they'll be in the middle. All right. So these are three cases. This is the case of partially immersed. Partially immersed. This is the case of floating, sinking. Students, it's all because of buoyancy. So what is buoyancy? And based upon buoyancy, what is Archimedes' principle, you're going to understand today. You're also going to understand when the king asked Archimedes, see Archimedes, whether this gold crown is pure or not. He found out. How? So before understanding buoyancy, first of all, you need to understand what is density of a material. Student, density is represented by rho. Density of any material is mass of that material divided by the volume it occupies. Now, density is mass by volume, so its units will be, unit of mass is kilogram. Make sure K is small, divided by, in SI system, if you write unit of mass in SI system, volume should also be in SI system, so it will be meter cube. All right. So students, what is density basically? Density is, you can also say, mass of unit volume of a substance. Unit volume of a substance. All right. Let us see what is density of water. You listen to this carefully. You become engineer tomorrow. You'll never forget. Students, imagine you have a container. This container is basically, it's a cube. It's a cube, perfect cube. And students, imagine that this container, every side is 1 meter. Every side is 1 meter. 1 meter, 1 meter, and 1 meter. Here's your cube. All right. Now, every side is 1 meter. Now, what will be the volume of the cube, students? Volume of this cube. Anyone can tell?
1 meter.
1 meter cube.
1 meter
1
cube.
meter cube. Very
1
good.
meter cube.
Volume, beautiful. The volume of this cube will be 1 meter cube. All right. Now, I ask you, you take some jug or you take some mug. All right. In that mug, you put 1 kg of water. How much water? 1
1 kg of
kg
1
of
kg.
water. You fill it. Let's say you fill this mug with 1 kg of water and you put this water in this. Okay, initially it's all empty, nothing is there. It's a cube, every side is 1 meter, its volume is 1 meter cube. You take 1 kilogram of water, you measure exactly 1 kilogram of water in this, put it inside this. So some water comes here on the bottom. Now, my question is, in order to fill this tank, whose volume is how much? 1 meter cube.
Cube.
This is the volume of the tank. How many jugs? How many jugs, or you call it mug, whatever you call it, or any container, having exactly 1 kg of water, how many times you have to put this 1 kg of water so that it would be brim full? The milk will touch the outer surface. The height of the milk, slowly height will increase, so it will be 1 meter. Means this cube is completely full. Can any student, 9th and 10th students, answer how many times the jug full of 1 kg of water will be poured into the tank so that the tank will be full? No more water can come in that. Any student?
Sir,
Any
one
rough guess?
time.
How many times?
One time.
Uh, you see, student, 1 meter is very big length. 1 meter is like if you extend your arm from one end of the arm, little left of your chest or breast, that is 1 meter. So imagine if so big tank is there, and if you put 1 kg of water, with 1 kg it will be full. Don't you think it is strange? 1 kg milk is very small milk. 1 kg milk is approximately equal to 1 liter milk. And 1 liter milk hardly comes in 2 or 3 glasses. Am I right? So in 2 or 3 glasses, so big tank, can it be full, Mansimrat? Do you seriously think? In 1, 2 or 3 glasses of milk or 2 or 3 glasses of water, do you think this complete tank will be full? Any student, do you think it will be full?
No, sir.
Never.
No, sir.
It will not even wet the bottom surface of the tank, that 1 kg of milk or 1 kg of water. So any student can tell me how many times 1 kg of jug, 1 kg water jug will be put in this tank so that it will be full. Any student? The answer
Volume of
is
tank
Volume,
upon
volume,
volume of
volume
jug.
of tube and volume of the jug in which water or milk is poured.
that volume is given, na beta. That volume is 1 meter
Then,
cube.
then we will divide both volumes.
No. You don't have to divide or multiply anything. I'm just asking you a general question that if I have a tank whose volume is 1 meter cube, your answer is not there. Actually, it will be 1,000 times. What does it mean? 1,000 times you have to put, once you put the jug, 1 kg water is there. Again, second time you put the jug, now you have 1 more kg of water. Third time you put the jug, you have 1 more kg of water. Similarly, how many times you will put to fill it?
1,000 times.
1000 times.
1,000.
1000.
1,000 मतलब 1000 बार अगर आप एक एक ये जो जग है जिसमें 1 kg वाटर है, 1000 बार अगर आप 1 kg वाटर या 1 kg दूध, इन दोनों को 1000 बार अगर आप इसमें डालें 1 kg भर के, तो ये पूरा भर जाएगा. इसका मतलब ये हुआ स्टूडेंट्स, नाउ this 1 meter cube container is having how much mass of water? Can any student tell me? 1 meter cube, how much mass of water is there? Students, how much mass of water is there? It's full with water. Very simple.
1000.
Correct. Because 1 jug was having how much water? 1 kg water. And how many jugs we put in this?
1000.
1,000 jugs. So how much mass is there?
1000 kg.
1000 kg of water. Students, you can do this experiment yourself, but you have to maybe have, like 10 quintals of milk or 10 quintals of water you should have. Then only it will be full. So you can do it maybe with small 1 centimeter cube. If you have a small container, 1 centimeter cube, and you fill it with water, then if you weigh the mass of water, this same experiment can be repeated. Okay, so that means, students, in 1 meter cube of volume, how much is the mass of water? In 1 meter cube of volume contains how much mass of water? Say again.
1000 kg of water.
Correct. And what is density? Density is defined as mass by volume. So from this, we can find from this formula density of water. Now, if volume is 1 meter cube, we have done experiment. To fill 1 meter cube of container, how much mass of water was used?
1000 kg.
1000 kg. You students, you're not going to forget the concept of density, how big you become. So from this, you will remember, students, what is density of water? 1000 kg, because 1000 times we put the jug having 1 kg of water in it in this container to completely fill it. And the volume of the container was 1 meter cube. So tell me, students, what is density of water? 1000 divided by 1 is 1000
1000
kilogram per
per
meter
meter cube.
cube. Wow, that's beautiful. Sargun, did you enjoy?
Yes, sir.
Oh, that's great. So density of water, we got a understanding. The density of water is in 1 meter cube of container. How much water is there? 1000 kg. Okay, imagine, students, if instead of water, if you had filled that same tank, if you had filled the same tank having a volume of 1 meter cube with mercury instead of water, then we could have calculated the density of mercury, Hg.
Mercury.
So students, suppose now what you do? Now what you have to do? Now you have to, suppose you have to put again lot of mercury. You keep putting lot of mercury. Let's say you have another tank full of mercury. You pour this tank into this and completely fill this 1 meter cube of tank. Now, if you weigh that complete tank having a volume of 1 meter cube, having complete mercury inside it, very heavy metal. It flows, but it is known as metal. It's flowing metal. It's probably the only flowing metal. Metals don't flow, but this metal flows. It has shining also, but it doesn't give a kink, if you, tick on this, like other metals. So it's a flowing metal, mercury. If you weigh this, students, it will be a great weight. The weight will be 13,600 kg. In the same volume, how much was the volume of tank?
1
How
meter
much?
cube.
1 meter cube. From this, we come to know what is density of mercury. So students,
Mercury.
density of mercury is 13,600 kilogram mass by volume. Volume is meter cube.
Meters cube.
Meter cube. Never meter square, meter cube. So this is equal to 13.6 times the density of water. Mercury is 13.6 times heavier than the water. So this is equal to 13.6 times. What is density of water? We just know. What is density of water, students?
1000
Thousand
kilogram per
gram
meter cube.
Per
cube.
meter cube. And when you multiply, you get the same density, 13,600 kilogram per meter. Students,
Kilogram.
I give you one trick. I'm not a really good teacher, but I'm giving you a trick. If you write units with whatever you write, you are going to become great in physics or mathematics. A simple trick I'm giving you. Always write units. Units will tell you so many things about the quantity, about its physical nature, about its mass, about its behavior also. Unit is a great thing. So guys, now everyone knows the density of water is how much? Can I ask this to
Kilogram per meter.
Pranav? What is density of water? Pranav, what is density of
1000
water? 1000 kilogram per
kg
meter
meter cube.
cube. What does it mean, Mansimrat? What does this mean expression that kilogram per meter cube? What does this mean?
So this means that we can put 1000 kilograms of water in 1 meter cube.
Of
1 meter
container.
cube. Yes,
Beautifully
sir.
expressed, Mansimrat Kaur. Beautifully expressed. Very good, bache. Very nice. So density of water is very important. Students, density tells us about how heavy some material is. Am I right? Right? How heavy some material is. Okay,
Yes, sir.
density tells us a lot of things, you know. Students, density of water is 1000 kg per meter cube, and density of sea water. If you happen to go to Bombay and you see sea water, it will be little more. It will be more than 1000 kilogram per meter cube. Do you know why? Anybody knows? Anybody can guess?
Because it
Because of
contains
salt content.
salts also,
It
Sir,
can
because
many
yes,
And
sir.
impurities and
energy
salts.
also.
beautiful, beautiful. It contains a lot of salt. In fact, salt is obtained from seawater by some chemical processes. So it has salt. So in the same container, 1 meter cube, 1000 times that water will come, but that water will be having additional mass of some impurities and and some maybe some minerals also, plus mainly salt. So if you see on the Google, students, the density of seawater is more than density of water. Now, one more interesting question about density. Go as deep as you can. Students, imagine you are having your hand. Let's say this is your hand. Okay. In your hand, you have some water, maybe 5 spoons of water. Okay. And then you have a small container. In this, you have 5 kg of water. And then you have a big container. This container is, let's say, having a volume of 10 meter cube. So you have a lot of water in this. Student, if I measure mass of this by volume, if I measure mass is 5 kg by the volume it occupies, and then if I measure mass of this divided by the volume 10 meter cube, do you think in all the three cases, density of water will be different or same?
So same.
Beautiful. Density of water would be same. Reason? Density is equal to mass by volume. As the volume increases or decreases proportionately, mass also increases or decreases, making density constant. But one thing is there, in that water should not be seawater. That water should be fresh water from the same source. Then the density of all will be same. Great, students. I'm happy. Okay. After that, I'm going to also tell you what is relative density. What is relative density? Students, if you have density of any substance, if you divide that density, this is rho, by density of water, That is known as relative density. Why that word relative? Density of water relative to density of any substance relative to water is known as relative density. Relative RD. Okay, relative density. Okay. So students, can anyone tell me, suppose a substance is having a relative density of 2. See, relative density does not have any units. Why? Imagine that some substance is 3 times more heavy than water. So its density will be 3000 kg per meter cube. And density of water is
Because the units gets cancelled.
1000 kilogram
kg
per
per
meter cube.
meter cube is equal to 3. It's just a number, relative density. So students, suppose Mansimrat will not answer this. Anyone else? Suppose the density of some substance is 2. Relative density of a substance is 2. Can Monrose tell me what will be the density of that substance? Monrose or Hamza or Amritpal Singh? Relative density of that substance is 2. What will be the density of that substance? Okay, now anyone? Anyone?
600 kg per meter cube.
No.
Why?
No. Now don't speak. You have answered. Now chupro. Let any other person ask. The relative density of some substance is 2. What will be its density? Nobody? हाँ बोलो यार. Don't raise hands. बोलो.
2000 kilogram per meter cube.
Beautiful. It will be 2000 kilogram per meter. Sargun, why you're not answering? Okay. So see how she found out? It's very simple. Relative density is 2 is equal to density of that substance by density of water. So do cross multiplication. Density of substance will be 2 into density of water. That is 2 into 1000 will be 2000 kilogram per meter cube. Okay. Now students, we have 10 more minutes. I want to ask, suppose the density concept is clear to you. Now we're going to understand why substances float, why some substances sink, and why substances partially immerse. Partially immerse means here is a substance. Okay, this is any liquid, not necessary water. Okay, this is any liquid, not necessary floating. Floating is the substance is here. It may be a cork or foam or wood or plastic. Anything. And not anything, I'm sorry. Particularly these things whose density is less. Okay. So imagine that we are having the liquid water, H2O in all. Okay. So when the substance will float, do you know students, when the density of the substance is less than density of the surrounding. And now for that substance, what is the surrounding? It is the water.
Water.
So that means whenever a substance will float, its density of that substance will be less than 1000
Density of the water.
per meter cube. Okay. Now, students, the density when that substance, this is floating and this is sinking. Sinking means the substance will come to the bottom of the container having water. You know why? Because this substance, students, this substance, any shape it will be, it may be iron, it may be any heavy metal. They all have density more than water. So density of substance is more than density of water. It will come to the bottom. And you know, students, very interesting. Can anyone tell me what will be relation between density of substance and density of water when it will be in the middle? Or you can say it is partially immersed?
They both are equal.
Both
Both
are
are
equal.
equal. Perfectly right.
Are equal.
When the density of substance is equal to density of water, you know what, guys? The substance will be somewhere in the middle. If you put it here, apply some force, it will be here only. If you put it here, it will be here only. So this is like how when the substances will sink, when the substances will float, जिसको in Hindi we say तैरना, or they'll be partially immersed. Students, why it happens? Can anyone know why? You may not be able to answer. In our next video, we will study what is buoyancy. Once you understand and deeply understand what is the force of buoyancy, which always acts in the upward direction, contrary to the force of gravity, which always acts in the
Upper direction.
Downwards.
downward direction.
Direction.
The gravity always acts in the downward direction. Very strange. The force of buoyancy, FB, always acts in the upward direction. Students, it is the force of buoyancy which is acting on the surface, which is making it push to the surface. It is a force of buoyancy which is less in this case, which is not able to uplift the heavy material, so the material comes down. It is a force of buoyancy which depends upon density of the substance which is immersed, as well as on the density of solution in that it is immersed. So students, when the densities are equal, the force of buoyancy is exactly balanced by the weight of the substance. In this case, they are equal, so the substance gets partially immersed in the solution. You know, students, I really can tell you, you listen to our lectures with the grace of God, you would definitely start loving physics. We can guarantee you that. But then there are lots of concepts in every lecture. So once you miss some lectures and then understand later on, you will understand that the concepts are becoming far behind. So you not only learn concepts in our lecture, but also go beyond the book, go beyond the concepts. I wish you all the best. Take care. If you like this, do share with your friends. Goodbye.